Hello everyone and welcome. In today's video I'm going to be talking about the BB30 Bottom Bracket standard. I'll talk about the history, where it came from, some of the bicycle manufacturers that use it, the good points, the bad points, some of the issues associated with installation, and then finally at the end of this video I'll show you how to fit an alternative crankset, say a Shimano crankset, onto a BB30 Bottom Bracket. Right, so the BB30 Bottom Bracket standard was developed by Cannondale, and it was a result of them trying to pursue a goal to reduce the weight of the crankset. Now, other manufacturers that use the BB30 standard are BMC, like my time machine behind me, Time, Look, Giant, Merida and Canyon. So there's a number of big manufacturers that use the standard. It's an open standard, so that means anyone can use it, and I've put a link down below in the comments box or description box so that you can download the drawings if you wish. So at the time the stand was developed, it was a bit of a cultural shift from the standard items of the time. So if we take a Shimano standard bottom bracket bearing, so one of this size, the BB30 bearing is that size, so it's considerably larger. What Cannondale did was they standardised on a 30mm axle, and the 30mm is purely because that's the next biggest size in a bearing catalogue and standard bearings. They also went and made it a direct fit. So whereas previously the bearings were in a threaded arrangement and they threaded into the bottom bracket shell, now the bearings just literally push directly in. What I've done is I've made my own fake BB30 bottom bracket. Now this simulates what you would have on a normal bike. So in terms of the shell width, which is across there, that is 68mm. So if I can turn that round, hopefully that will say 68. It does, 68.17. The hole in the middle where the bearings go through, that's nominally 42mm, and the exact dimension of this opening needs to be a slight interference. That's 41.96mm to be precise. The major advantage with the Cannondale system is the system weight. So it just consists of two bearings and two snap rings, just like that. So the combined weight is very small. So if we just weigh them. So for system weight, I've gone and got a standard Shimano bottom bracket. It's threaded and it's a ISO standard or BSA bottom bracket. So it's 1.37 by 24. That actually means 1.37 inches by 24 teeth per inch. That weighs 65 grams, so that's bearings, sleeves, everything, put that through. The shell width on a BSA bottom bracket is also 68mm, so just to prove that, 67.73, so it's near enough. The the Cannondale standard has two bearings and two snap rings. So the combined weight there is 46 grams. But the bit that's not immediately apparent is the rest of the gubbins that you have to have in the bike frame in order to take this type of bottom bracket. So you will need a threaded shell, which adds to the weight of the bike. Now to do a close-up of the bottom bracket shell, this is my dummy unit, but the dimensions are the same. I've already explained that the hole needs to be slightly under 42mm, so 41.93. It's actually a bit bigger than that, but there's some inaccuracy using a vernier. The shell is 68mm, 68.06, and inside, I don't know if you can just make out, there's a groove in there, and that is for two snap rings that fit in either side. So they are there to axially restrain the bearings. To install the system into the bottom bracket shell, you have two bearings and two snap rings. Now these snap rings are actually quite important. These are genuine snap rings, they're smally snap rings and they fit really well. However, there are some people that use this type of snap ring and that is not really designed for this system. If you just overlay the two together, you can see that at the periphery the smally ring is fairly constant in radius, but the external snap ring or circlip is much thicker there than it is around the sides, and that can actually impinge the bearing, so that's something to avoid. But as far as fitting these, you can actually fit these by hand, so just slide it into the hole and push. Once you get it in, you just literally snap it into the groove and it's secure. Do the same thing on the other side. Again, it's secure. So they're the two axial restraints. Then it's just a question of pushing the bearings in. So from either side, we just literally push in like that. Now there are multiple techniques to do this, and obviously my fake bottom bracket here makes it considerably easier than on a bike frame, but the principle is the same. Just use two presses and push them in like that. I didn't bother showing you how I pushed it in, but that's the system complete. So we've got the bottom bracket shell, bearing on that side, bearing on that side, and there's absolutely nothing in between. You should be able to just make out the circlip in the the snap ring in the background. So what are the good points about the BB30 system? Well, you've seen a couple of them, and one is the weight, so it's significantly lighter. It's just only the weight of two bearings. The other thing is the bearings are big. Bigger bearings will last longer. The oversized axle is comparatively stiff, so if you go from a 24mm axle, which is what a Shimano crankset uses, to a 30mm axle, that will inherently be stiffer purely by geometry. The other aspect is a biomechanical aspect, which is to do with something called ankle clearance. Now, ankle clearance does not affect everybody, and it's to do with their feet positioning on the pedals. So if your feet toe outwards quite considerably, that moves your ankle towards the centre line of the crank. By having a very narrow bottom bracket, which this is, then you can increase that clearance. The problem is only Cannondale and a few other manufacturers use that, and the vast majority actually use the Shimano standard, which is basically 90mm across the drive side to non-drive side, whereas this one is 68. Now, BB30 has got a number of problems associated with it. If we talk purely about the performance issues first of all, and they're related to how narrow the bottom bracket is. So the distance between the outside of these bearings is nominally 68mm. By having the bearings that close together, the system is not as stiff as if you would have the bearings further apart. Now, to illustrate that, there's no easier way than if I use a ratchet. So here we have a ratchet with a socket on the end. When I put the socket directly onto the ratchet, or wrench for my American viewers, turn it, I have my hand there and I don't really do anything with it, just turn it. If I put an extension on that and turn it, what my natural inclination to do is to put my left hand there to act as a bearing. But human nature will put my left hand up towards the axis of rotation as opposed to down here. And if you think about that, that's not really too indifferent to our BB30 system. So your feet are in virtually the same position, but the bearings are closer together, so they are stressed more. The other thing is the BB30 system bearings are bigger, and bigger bearings actually have more friction. It's not much, but it's there. The final aspect, which is a bit of a bugbear of everybody, I guess, is creak. Now, my bottom bracket shell is precisely machined in metal, and therefore you can obtain very, very accurate manufacturing tolerances. When they do this in carbon, the manufacturing tolerance they can obtain is not as accurate. It's just the nature of the material. And the other thing is the way this is manufactured. So when I made this, I drilled purely from one side to keep everything in line. So I drilled that side, carried on through, and then drilled the other side, but only from one side. Bicycle manufacturers want to cut costs. What they tend to do is drill from one side, flip the frame over and drill from the other side. That is not as accurate, and that's one of the reasons why you get creak. So there are a number of installation issues you can get when you install BB30 bottom brackets, and the first one I alluded to earlier was the use of snap rings. Now, the smally snap rings are by far better than these ones which require circlip pliers. They fit better in the groove and also do not impinge the bearing anywhere near as much. So I don't know if the camera can make that out, but you can see how much of a squeeze you've got to get on. The other things that can cause problems are to do with creak. Now into an aluminium frame, you don't usually get this problem, but certainly into carbon you can. But the first thing that people use is retaining compound. The retaining compound is there just to fill the gap between the outside of the bearing and the bearing shell, just in case it's irregular. On an aluminium frame, that's not generally required, but that's one thing to use. On carbon, it's a different ball game altogether, because the retaining compound does not work well directly onto carbon against a hardened steel surface. So this Loctite activator 7471, which was recommended to me by the Henkel man, who make Loctite, is very, very effective. So it makes the bond much, much stronger. Quite a lot of people just use the retaining compound and don't bother with the activator, but if you've got a carbon frame and you're having these problems, then that's what I would go for. There aren't really any other issues in terms of installation for creak, other than basically the bearing is moving inside the shell, and that's what causes the creak. There's no real movement inside the frame per se, it's just purely a relative movement between the bearing and the shell, and the retaining compound is there purely to reduce that movement. I should really say a bit before moving on about manufacturing tolerances, and that's to do with the hole that's in the bearing shell. You absolutely need to make sure that is around 41.97, 41.98 millimeters. If it's any bigger than that, then you run the risk of the bearings simply falling through. The other thing is the use of poor quality bearings, so eBay bearings. The manufacturing tolerance actually on the bearing can either make it much bigger than normal or much smaller than normal. Now, Cannondale stipulate 61806 bearings. By stipulating the one in there, they're defining an ISO standard which has P6, P5 tolerances. If you deviate from that and buy a no-name bearing, probably from eBay or Amazon or somewhere like that, then you run the risk of the bearing simply falling out, and then you have to just reach for the activator and retaining compound. Or if the bearing's really, really tight in there, the bearing will click. As you install it, it'll feel gritty, and that's a telltale giveaway that there's some sort of mismatch in tolerances. So there's grittiness or it's loose. Either of those two scenarios is a bad idea or a bad day. So for the last part of this video, I'm going to show you how to fit a Shimano crankset into a BB30 bottom bracket. There are a few ways to do this, and I'll describe the vast majority of the popular ones. So there's our BB30 bottom bracket system, bearings, circlips and the shell. The easiest way to adapt the system to take a 24mm axle, which is what a Shimano setup is to use these things, which are adapters. Now, I've made these, and I'm going to put a drawing in the description box below so you can make your own. They're not particularly difficult to make, and they're not particularly expensive. even to buy. You can get them from well-known internet retailers. They literally just slide into the bearing like that, push in, and then push in the other side like that, and you just put the axle through. That's it. Disadvantage is the bearings are still in a narrow position. They're still at 68mm, as opposed to the BSA bottom bracket, which has the bearings in these black sections here, so it's much wider. So the nominal 90 versus 68. A few other ways are you can have a 3-piece bottom bracket. So here's another one I made. So literally the cups go in either side, and this sleeve is just there in the middle. Okay, the issue with that is one of alignment, not particularly my preference. Now when I first bought my BMC bike, I used this bottom bracket, which is from Praxis Works. Semi-threaded, and it's designed to splay outwards as you tighten it. Now there's not really that much wrong with this bottom bracket, apart from one aspect which I really dislike, and that is this O-ring seal here. Now when you put that on and tighten it, it feels almost like it's loose on that side, and it really did put me off. So I binned that bottom bracket and then decided to make my own. Now you've obviously seen the system is like that, which is just 2 bearings, 2 circlips. I replaced the entire section with 1 piece. Now this particular bottom bracket that I've got in my hand is titanium, and the reason for that is I ride my bike in winter and I don't want anything to rust. So titanium, an expensive solution, but it works and there's no problem with it. So if we go over to my BMC time machine, I can actually explain how this system works. So this is my BMC time machine. I bought it as a frame only a while ago, and when it came it was absolutely bare, so I had to put my own bottom bracket in. The frame itself is BB30, and I'm running Shimano Dura-Race 9000 group set, and these are the OEM cranks, well not OEM, well Shimano cranks that I brought from my previous bike and I wanted to carry on using them. So I had to adapt the BB30 system to take a Shimano crankset. There was a few things that I tried first of all, and the fastest one, just so I could ride the bike, was to put 6806 bearings in and then use these adapters that I mentioned earlier to get me going, really, more than anything else. Performance wise, it's not acceptable for me. Even with my modest FTP of 230, I'm not going to tear any trees up. I wasn't happy with it because I thought there was a bit too much flex, if that's the right word, in the system. So the next thing I tried was that Praxis Works bottom bracket that I mentioned earlier. Again, not great. That rubber seal on the end, plus the amount of tightening you have to put in, really didn't fill me with joy. So then I looked at the BMC racing team to see what they were using, and they were using these 3-piece bottom brackets. So a drive end cup, a non-drive end cup, and a sleeve that goes in between. Now the drive end and the non-drive cup are basically symmetrical. So the drive end cup goes in, non-drive end cup goes in after the sleeve. So that gives you the right spacing for the Shimano bottom bracket, Shimano crankset, so it's 90.5mm and a 24mm hole through the middle for the axle. Again, I wasn't happy with this because I was going through bearings pretty quick, so I figured out there must be a misalignment issue somewhere in the system. So I dismantled this and then took the bike to work to get it measured with a laser. So I'm an aerospace engineer, so I actually measured the discrepancy between the non-drive side and the drive side, and it was 75 microns, which is 3/1000ths of an inch. So to me, 3/1000ths of an inch or 75 microns on a space of 68mm is absolutely unacceptable. So what I did was I developed my own system, which is this 1-piece bottom bracket. And the only caveat with that is, well, this is a copy of the shell that's in here. The only caveat with this is you need to be able to see all the way through. On this bike it was no problem, but on my Cervelo bike there was a Di2 wire that was in the middle of here, and that wouldn't allow me to press a one-piece bottom bracket through. So what I had to do was I had to unclip the Di2 wire, move the junction box, reclip it in, and then push the one-piece bottom bracket through. This is the one-piece bottom bracket. It's basically designed by me. I'll put a description, I'll put a link to some drawings in the description so you can make your own. If you want to purchase a ready-made one, I'll gladly sell you one. But I'll show you how this is installed, because I think it's dead easy compared to the vast majority of other bottom brackets. So here we are back at my workmate, and with a copy of the bottom bracket shell from my BMC time machine. So it's 68mm and nominally a 42mm hole, well it's slightly smaller. And this one piece bottom bracket, so it has the bearings already installed, and literally all we're going to do is push this in. Now I've designed this so that you can actually do it with a G-clamp. You could use a standard bearing press, which is one of these. But for the purposes of this little demonstration, I'm going to use that quick clamp. So all we do is, this is the drive side, and we're just going to push this in with the quick clamp. Now as you push in, it will go loose like that, and that's just because the centre of the bottom bracket shell is slightly wider than the two ends. So we continue to push, try and get it as lined up like so, and then you feel it go stiff, and that's because at the other side it's now flush. Reach for the spacer. Again, I'm going to put drawings in the description so you can make your own. Withdraw the quick clamp slightly and then continue to clamp. And that's it, that's installed. So now we have very, very good alignment between the two bearings. There's only about 5 to 10 microns of misalignment, and that's because the alignment is carried by the bearing sleeve and not the machining process in the bike frame. Admittedly, this bottom bracket shell which I've made, or a dummy, is well machined in terms of tolerances, but with this type of bottom bracket, the one piece, you've got very, very good bearing alignment. The space between the two bearings is absolutely as Shimano intended. So it's probably as good as you'll get. Now I've measured the power difference between 0.1 millimeters of misalignment, which is 100 microns or 4/1000ths of an inch, and this one 5 to 10 microns, and it's about 3 or 4 watts, and that's quite a lot if you're going quite fast. Now if you're not going that fast, you probably won't even feel a difference, but where you will feel a difference is in the bearing life. Better bearing alignment gives you better bearing life, so that's why I developed this. The other thing I wanted to do was make it easy to dismantle and remove the bottom bracket, so I'll show you how to do that as well, again with a quick clamp. So to dismantle it, you're going to need well, a few sockets, and they're really just spacers. But this is the critical tool, which is the removal tool, and it's just a sleeve. Again, I'll put a link and a link to it in the description so you can make your own. So slide this over the end of the bottom bracket, and then, no, it's not quite enough, till it's flush with the end, and it's halfway out. Then we can install the park tool or a socket, continue to press, and now it's semi out. Okay, drop the tool in there, and then we just need a socket just to bridge the gap. Continue to clamp. So there's the shell, and in here is the bottom bracket, so no hammers required. You can once again use this type of bearing press tool, but it's not totally necessary. Just a cheap quick clamp Irwin quick grip will do the job. So that's kind of the end of this video. So I've really talked about BB30 and what it all entails and some of the benefits, the drawbacks, and if you want to use an alternative crankset like a Shimano in it. If you enjoyed this video, please give me a thumbs up, and please feel free to subscribe, and also visit my website, which is hambini.com. There will be a set of links below this video so that you can get full drawings and stuff for basically what is an open source bottom bracket design. Thanks very much for watching, and until